Okay, recording has started.
So welcome. I don't know if there's any newcomers in here today. If you want to introduce yourself, feel free to take a second. No, we're all regulars. Cool. All right, so I didn't think we'd have enough on the agenda, but it filled up pretty quickly. So we're going to kick today's meeting off with a short discussion from Amir, and then Jordan and Dan have some stuff to talk about. I think Dan's even going to do a demo on some work they've been doing. So Amir, why don't you kick it off?
Wonderful. Thank you so much, Kim. Hello, everybody. Looking forward to updating the work group today on the results of the security review that I first alluded to back in October. I created a quick document to share with everybody, just that kind of captures some of the main information. It's directly in the agenda as well, if you'd like to follow along. But again, yes, thank you so much. I'm excited to talk to you about this review. The review took place over Q2 and Q3 of last year. Linux Foundation sponsored the review, and OSTIF facilitated and championed the review through to completion. It was a really unique project, fun project that involved a coalition. It involved putting together a coalition of people from Linux Foundation, mainly the kernel development team, Google, Red Hat, all working together to maximize the value of this review. And as I mentioned, yes, some of the key information has been captured here for everyone to review. But the objectives are listed here, the main things that were reviewed, the scope being mostly focused on security vulnerability disclosure, evaluation and remediation, as well as tracking. And the impact of this work, I'm sorry, and then so going down, the conclusions of this review were that the process for evaluating and patching bugs within the Linux kernel development may not be perfect, but they are effective. And taking all of the research that was done, two main recommendations came as a result. The first one was that the Linux kernel moved to a public security bug reporting system. And the reasoning for that is well documented and explained within the report, as well as the recommendation number 2, which is CVE reporting should reside with downstream distributions. So I know those are two pretty simple things that can cause some discussion. My intention for today was more so just to update everybody and to go over these findings with everybody. I highly recommend reading the report to see really the nature of the research that was done and how those recommendations came to be. And I'm hoping that if that gets everybody excited enough and we want to have a deeper discussion on those findings, we can definitely do that as an agenda topic for a future meeting. But really quickly to go over the impact of the work, it's great that there is now well-executed research on the Linux kernel, including the creation and documentation of some key processes. And this research serves as a catalyst for additional discussions and long-term action to achieving the best possible security outcomes. So with that, I thank you all again. Thank you for giving me your time to update you all on that. I definitely invite you to discuss anything security related, especially when it comes to audits or security reviews with us. Myself and Derek couldn't be here today. Unfortunately, he's a little under the weather, but I'm definitely open to any kinds of discussions of that nature. And yeah, hopefully we'll have more work and more results for the work group soon. So with that, again, thank you. And yeah, any questions, feel free to, I don't want to kind of take up the whole meeting. So I was thinking if we want to do any questions, I can maybe take one or two if I'm able to answer them, and then if warranted, we can discuss further at a future meeting.
I'm just curious, how's the feedback been so far from like the Linux kernel community on this?
From the community, I'm not entirely sure.
I can jump in a little on that if
Okay,
you want.
yeah,
Amir.
please.
Okay, yeah. So Greg KH and I both saw this, and I think I think we basically came to the same conclusions in terms of response to this. The first one, I think certainly Greg KH and I don't. While we have questions about that first one, I don't think the Linux kernel is actually going to move to a immediately public viewpoint. I think both Greg KH and I have significant concerns about that. On the other hand, we thought that was one heck of an interesting recommendation, and it's hard to, given both of our pushes about we want things more open, saying, hey, we want a group that says you should be even more open is an interesting perspective. And so we thought, well, we're not so sold on it. They make some good points. Let's get that report out and hear what other people have to say, because it is an interesting idea that has not been seriously pitched before, I don't think. As far as the second one goes, I think there's general unanimous is probably impossible, but I think there is general agreement in the kernel community that it makes sense to have the CVE CVEs devolve on the kernel, devolve down. Part of the problem is the kernel is used in so many different situations that what is a really big vulnerability in one situation is completely irrelevant in many others. And so it's very, very difficult to have a single spot. So I think things have been moving in that direction anyway, but this gives much more of a yes, this makes sense, and in fact push harder in this direction. So questions about the first, but I think legitimate and worthy of discussion, and the latter I think absolutely I think there's general agreement.
Is there a discussion like on Hacker News or anything for the link, Amir, that people are discussing? Or
I'm not entirely sure about Hacker News just yet. This is all relatively new. We just did publish this, but I'm not too sure if it's on there yet. But I wouldn't be surprised if it made its way on there, or
it'd just be fun to follow along. If it's
yeah.
I think the post everything public, it would be unsurprising to end up with big discussions in Hacker News.
Yeah, but to your point, David, the fact that there is a referenceable body of research done that's well founded, that can serve as a catalyst to document this stuff and move it along in the right direction, as David mentioned, I think is some of the real value in this review.
Cool, thank you, Amir.
Yeah, thank you.
Another question? Are you ready to take it away?
I think, I'm ready for whatever's next on the agenda.
Cool. Actually, the order here, we put Newton last, but I think for my demo, Jordan and I were just going to chat a little bit about some upcoming work, so maybe it makes sense to move that one to last. Okay. Some discussions. You want to talk about the criticality score research you did, Newton, if you're here?
Yep. Can you guys hear me?
Yep.
Yeah.
Okay, awesome. Hello, everyone. Again, thank you for the opportunity. I just wanted to sort of revisit something that I did after our meeting the last time we met. We looked at the criticality score. I got introduced to Abhishek, and we had a email communication as well. Because I did a project while I was a grad student at RIT, which was very similar to what the criticality score is about. I think Chris Hahn, my colleague, mentioned it. It's called Reaper. I've linked it in the agenda as well. So it seemed very similar, and we had a bit of an email communication with Abhishek, and he said that yes, some of the metrics that we collected as part of the Reaper project are being collected as part of the criticality project. So that's good. But Abhishek also mentioned that Reaper is based off of this project called GHTorrent, which has been inactive for a while now. Since it was funded by Microsoft, there was a bit of a snafu with how it moved away from the researcher who did the GHTorrent into Microsoft. It was supposed to become an internal research thingy that never went anywhere. But yeah, so I was curious, and so Abhishek shared some of the results from the criticality score, and I opened up the CSVs, and I looked at some of the top-rated projects in terms of criticality, and all of them were familiar projects. They're all some of the most popular open source projects in the respective programming languages. So we said, is there, are these just the criticality score is very similar to the popularity of these? And I looked at the Hacker News discussion about the criticality score, and some of the comments on that post were also asking the exact same question. So we said, why don't we just run a quick evaluation of that? So we did that. I posted the results onto the Google group conversation. I've linked that conversation in the agenda as well. So we found that there is a positive correlation. Yes, there is a criticality score is positively correlated with popularity. I use the number of stargazers on GitHub as a measure of popularity. But the effect is not as strong. I expected it to be the high, 80.8 Spearman's row correlation coefficient, but it wasn't anywhere close to that. So yes, criticality score is essential in terms of it being it giving us more signal than the popularity is giving us. So in the end of that discussion, I think Dan recommended that I write up the methodology. I have written that up. I just want to contribute that back into, I don't know which repository I should be contributing that back to, so I'm looking for some guidance from this group. It's a markdown, so if you want to put it as a wiki in a project, you could. If you want to put it as a GitHub markdown file somewhere, I could just send it to this group. So yeah, I just wanted to touch upon what I did and just share the results and see if anyone had any questions or follow-on work that we think we could do in terms of this criticality score.
Quick comment. I don't think the wiki is used for anything else in this project, so I think you'd get way more visibility putting it into the main project itself.
Okay, and would that main project be the WG Secure and Critical Projects repository?
That sounds right.
Either that one or there's the criticality score one is the one that actually has the code, and I think there's another little PDF in there explaining the initial algorithm. So that one might make more sense. I'll drop a link in here.
Sure, I'll just clone that and open a pull request.
Awesome.
So another item on the agenda, it's again related to what we're doing. Criticality score, as I mentioned, is similar to what Reaper did, a few years ago. Obviously, that data set is wildly out of date now. We ran that last in April of 2014, I think. I'm also curious to see how correlated the criticality score is with the score that we computed. And the reason I want to do that is because we already have this data set of a few million repositories that we scanned over an entire summer. We used all of the compute at the university to do that. So if we can get a high enough correlation, then we automatically have a much larger data set of critical projects. So that's something that I want to sort of extend this analysis into in the near future.
The data scale issue has been a problem for us for a while. You mentioned GHTorrent.
Yes.
I didn't quite catch what you said about it. You said, I know the researcher on it has kind of moved away from it, or it's not quite being actively updated anymore. Do you have any more information on that?
Yeah, so from what I know, Microsoft was sponsoring that project. So they were giving the project Azure Data Lake Storage, I think. They were slowly moving the repository out of the GHTorrent database out of MySQL that was hosted on-prem onto Azure, because they gave them 2 years worth of credits. That's the last I heard of it. And recently when I checked, they used to release an update every now and then with every new mine that they did of GitHub, but I haven't been seeing any new updates coming off of that. And I think the way they got around the data scaling issues that I think someone mentioned in the email chain was just asking the community to share their GitHub tokens. That's pretty much what we did with Reaper as well. We essentially asked our entire class of students who we were working with to volunteer their GitHub tokens for us. over the summer. So that's how we got around the data scale issues. But again, this was much earlier, and I think GitHub has gotten a little bit more strict with the API rate limiting. So yeah, I don't know how that's going to fly now. And in terms of the project I mentioned, so Microsoft was working on another similar project called GH Insights, which was very similar to Reaper. And I was supposed to work on that project, but that again got shelved. It was supposed to be exactly that, an internal tool that you could use to collect metrics from repositories and understand how they're doing. But again, I haven't heard anything since like 4 years ago.
I know Abhishek's been asking some people at Microsoft and GitHub for ways to get more tokens and everything. I don't know if you've heard back anywhere yet, Abhishek.
No, nothing so far. So still optimistic, but yeah. Till then, like I have 3 tokens to work on things. So yeah. There is another thing I mentioned with respect to criticality score. So right now we are trying to just look at, let's say, critical projects, but another important point that people bring up is like which are the actual security critical part of those. Like there might be popular projects, but we only care about ones that expose like attack surface or can harm user data. So still looking for ideas if people have to decide that security bit part of it. Like if anyone has any ideas on that.
I think one example of that most people probably saw this week is the pseudo CVEs. If you look at that repo, it doesn't have too many stars, so it would probably not show up in any of these analyses we've done so far, but pseudo is a pretty security critical project. So yeah, any ideas for how to catch stuff like this in the analysis would definitely be useful.
I think my only idea was looking at like previous vulnerabilities and how severe they were, but I don't even know if they've all been filed for some of these projects.
Would looking at the bounty programs that some of these projects have give us an indication of which of these are actually security related and they're taking it seriously?
You mean like HackerOne, or what are you indicating?
There's also a Linux Foundation, okay. I think, or Open Internet, one of them. There's this umbrella bounty program that's funded by a bunch of organizations. So they give out bounties to anyone who finds security problems. So we could start with those projects as well, right? Because they're seriously, they're really concerned about security. That's why they're giving out huge sums of money to people.
Yeah, maybe we start a doc with a bunch of ideas and just throw them all in there and share it. I'll share it either this week or next meeting, and then any ideas, pop them in there. Cool.
Cool. All right, malware analysis. So Jordan's been doing a bunch of work on this project. We've got a little repo for. I'll drop the link in here. And I did some hacking on it earlier this week too, so I thought I would do a demo if people are interested. Do you want to get started first, Jordan? I haven't had a chance to catch up with what you pushed, but I just saw you mentioned in Slack something is ready.
Yeah, I can give a super quick update. So there's kind of 2 parts to the malware analysis project. The first is a project. You can imagine it could even be its own product, so to speak, which is essentially just a consolidation point that takes in updates from all the different package managers for different languages. You know, for PyPI is kind of the first one, but you can imagine NPM is another one. And it exposes those on like one queue to be ingested upstream. This could be for the criticality project. This could be for like dynamic analysis. You name it. It's just the feed that sends, you know, any and all updates to that ecosystem upstream. That's the part that I've been working on. And what I've merged recently is that we've migrated some of those bits to Cloud Run to make that a little bit easier in terms of adding new package manager support. And I've also been working on getting everything bootstrapped with Terraform so that as new ones are added, the infrastructure is managed for us kind of automatically. So setting up all the GitHub actions and stuff where once a PR is accepted, all the right infrastructure spins up and things just kind of magically work. So more to come on that. We've merged the Cloud Run stuff last night, except it was so late that whenever I merged it, I didn't realize that the PR merged into a branch. So we still have to get it into master or main rather. That can be done tonight. And then the Terraform stuff I was going to get done last night, but GitHub Actions had helpfully an issue whenever I was trying to get those tested and merged in. So more to come there, but that's the first part of that process, is getting all the packages kind of upstream to some of the work that Dan's been working on.
Cool. Yeah, so I'll share my screen and do a little demo. I've been hacking on the second half of this. It's all kind of based on Jordan's original work that he got set up here in this OSS malware repo and published a blog post a while ago. But the basic idea here, the type of malware we're trying to detect is packages that do bad things during installation. So a lot of programming languages and package managers like PyPy and NPM let packages run arbitrary scripts as they're installed. And there have been a couple, I think even this week, there was another report of NPM packages stealing like Discord credentials from people's home directories during installation and using that to do bad things. So Jordan's original code here ran, you can correct me if I'm wrong, but it ran the installation inside of a Docker container and then watched what happened with like sysdig and TCP dump to see if any network connections got made and what files got opened, and that kind of thing. Was there anything else you were looking for, Jordan?
No, and I think an important point is that it required a dedicated host that had to always be running. So that was kind of the downside of that approach.
Right. Yeah, so somebody pointed me at the Falco project earlier this week, which I had heard about but hadn't ever tried before, which is a kind of like exactly what Jordan did, but with sysdig inside of Kubernetes clusters, so you can configure it to watch all containers inside of a cluster. So I decided to give it a try on this one and wrote up a couple of configs. So I'll show what it looks like and then how it works. So this is the Falco language here. You describe different syscalls you want to monitor, and it's Kubernetes aware, so you can also do stuff like filter on the namespace and labels on your pods, so you don't watch everything running in the entire cluster. So I set this up to ignore, some files that you would expect a package manager to look at for downloading things over SSL, resolving DNS, and actually executing the Python script itself. And wrote these rules, then put together a little Go program to parse the results in real time as they get generated here. Falco just kind of exports them in JSON over HTTP. So this thing just listens to those, does a little bit of correlation, and then uploads the results to GCS, which is Google Cloud Storage. I was trying to see how it would scale. So I grabbed the top couple hundred packages from PyPy and NPM, stuck them here, a text file, and it seems to work pretty well. So I can, there's a little script that just creates a Kubernetes pod for each one of these that just does an installation and then gets deleted after. It takes a couple minutes just to get through 100 of them in this pretty small cluster I have. So it seems like it'll scale pretty well. We can do Python. This should create, people can see this. Yep, it's creating a pod for every single package here. I didn't build in any queuing myself. Kubernetes handled the scheduling and queuing, so the pods will just kind of sit pending until there's room for them to execute. You can see, I think I have the logs going here. For the Go program. So eventually, as these pods actually start up, run, we'll start to see a whole bunch of things here. This is from an earlier run. But right now, basically just logs every single file outside of those allowed directories that is touched by the installation of each one of these packages. And then while we wait for this to actually go, you can see what the results look like. I downloaded them from a previous run. So when you install the AWS SDK, and I'll format this. That works. It's happening. Oh, whoops. So you can see that when you install the AWS SDK, it just touches these files. Not really sure what it's doing with local time or anything, but that seems relatively safe. I didn't see anything crazy in here when I was looking, but I also didn't do any deep analysis on this. I think the next kind of cool step would be to hook this up into some database, like BigQuery or MySQL, where you could actually do queries and see which packages are touching things that aren't touched by other packages. And yeah, this is all published on GCS, so if anybody wants to download it and play around, they can, or add other packages to these lists and we can run it more. I tried to run it on the 3 NPM packages that were published this week to see if it would catch anything, but they were actually taken down and I can't find the code for them, so I can't tell if I would have caught those. I was too slow. So we can see the logs happening here.
Yeah, I was going to ask you if you have tested it out with known bad.
If anyone knows a known bad package, I'd be happy to try it.
Yeah, there is actually. Sorry, did someone else speak? Go ahead. Go ahead.
There was a couple people that reached out after my initial analysis that had done some work. Like one of them had a paper that was called like the Backstabbers Toolkit or something. I'll have to find it.
That's right.
They maintain these libraries and they've offered them up. So I'll get their contact details and I'll send them over because maybe that'd be a good test base for you.
Awesome.
Yep, that's actually the same group I was going to mention. Backstabbers Toolkit folks have a repo. It's not public, but if you request access and try to show that you're not trying to hurt other folks, they'll give you access. But that might be a useful way to test out some things.
So it's not actually something sitting in the registries. It's like just some code I can test out myself.
I've forgotten the exact form, but basically they made copies off of various things. So
cool. Yeah, I'll give that a try. I know you also did network analysis, Jordan. I tried to get that working, but was running into some trouble with Falco and decided to drop that for now. If something's going to exfiltrate your credentials over the network, it probably has to read them first. So I figured this is a good place to start.
Yeah, these can be taken in piecemeal problems, right? Because I had to do some magic to get that to work. Pretty much hooking up the networking up the TCP dump, and that's the hard part, right? It's like, how do we get this part of it working in both a scalable way, but also in a, weird packages aren't going to slow down the whole system kind of way, because that's something that I encountered was that, since the internet is just like the worst place ever, there's stuff on there that just, it doesn't do what you expect it to do. It doesn't cleanly install. It takes forever. And if there's limits and everything going through one kind of persistent host, for example, then that caused me a number of scalability problems.
Yeah, I was hoping this would just be nice because I can add more nodes to the Kubernetes cluster whenever and run it, and it's pretty horizontally scalable. I had some other ideas too, kind of making the container environment these are running in a little more attractive to things trying to steal credentials, like putting fake credentials in locations and that kind of thing. Just to see if anything opens up those, almost like a little honeypot technique. If anybody has other ideas or links to stuff like that, we can try sticking it in. Right now, it's just a basic Python and a basic NPM container, but we could definitely try to disguise things a little more. They have full dynamic, code execution, so somebody could look and see that it's part of this system and then not do bad behavior if this were to get productionized. So we're gonna have to come up with ways to hide it.
And what I love is that the more, because I had whenever the blog post was published and people on Hacker News were giving opinions, they one of the things that I heard was well, they would just fingerprint the system and then they would not detonate their malware. And one of the benefits is that by having such a vanilla container that it's running in, that matches a lot of people's normal production instances. So if the malware in question is like, well, this is a very bare bones NPM based container, if they choose not to detonate their malware, then they're actually missing out on a huge footprint of people, because that's otherwise a legitimate production system, right? There may be other ways that they could do some complex fingerprinting, but it certainly raises the bar pretty significantly.
Yeah, that's a really good point. If I make this look like a CI server because it is a CI server, then people have to not detonate in anyone's CI server.
Right.
Well,
I mean, I would say just in general, in testing in general, you should try to make it look as much as possible like the real thing. But in this case, especially so, to counter the anti-detection mechanisms a lot of these folks have. I'm sorry. Go ahead.
I was just going to say they're going to have to make syscalls to fingerprint the system.
Yeah, we can look for those.
There are ways to do it without, but I think that's hard.
The other, yeah, just thinking of just dropping some of those juicy looking files around too to see if that would help. My bitcoins are hidden here .txt kind of thing, and see what happens.
This actually raises a larger question, and I don't have a solution. But if everything is public, then the smarter attackers will look at your list of what the things you're looking for and try to avoid it. The virus writers have very much this issue where the first thing you do after you write a virus is make sure it goes to virus total and keep sending it until it doesn't detect it anymore. So I don't have a simple solution, but you might want to make it so that you can have here's quote the standard part, and then it would be easy to slip in some additional checks that maybe aren't as public.
And what I like is, it goes back to Mike's point, which is, let's say that we say we're looking at all syscalls and all network traffic. I will tell you that up front that that's what I'm looking for. So if you're gonna make malware, just don't use syscalls, don't use network traffic. And that with how much that raises the bar, and really what the way I responded to folks that were offering up those kind of perspectives was, my goal isn't necessarily to make this impossible. That'd be great, but it's also really hard. My goal is to make it much more difficult than it is today. And if we've done that, then I think we've succeeded quite a bit.
And even if we're not actually catching it right away, if we're publishing all the syscalls and network traffic that every package made for other people to go and look through, then maybe they can find stuff that we did miss.
Yeah, that's fair.
Cool. Yeah, so PR is welcome here if anybody has any other ideas.
Do you think could potentially we use this for detecting which projects are security critical? Just tying back the two conversations, see what files are being touched or anything, and this could give us a better indication of which projects might be more vulnerable to larger attacks.
I remember when Jordan first presented somebody had talked about, so this just does installation. People had talked about detecting at runtime, so after installation, run it and have it exercise some basic code paths. Because other packages don't do anything at install time, but they set up hooks so that when you import them in a real app, it'll look around for stuff. I think it's harder to write those test cases, but the nice thing here is that there's nothing about installation in this system, so you could extend it to do any kind of analysis if you can actually exercise the code. Well, that's all I had. It looks like people are dropping some other things into the notes now.
One thing I wanted to mention here was I really feel these package managers allow building from anything, not just the exact source code that it's supposed to be built from. So a completely different idea to think about, maybe can we have some system which just builds things from source and puts a verified label or something like that onto the things, which people can trust more. Right now it's more you can just build anything, upload anything. Obviously, there is a flaw, you can inject the malware inside the source itself, but right now it just feels like a wild, wild west, do completely anything and upload any binaries to a package manager.
Well, Chris actually had an item that he wanted to discuss about reproducible builds, which is kind of exactly that. Do you want to chat about that today, Chris, or is that for a future topic?
So the reproducible builds chat is with Chris Lamb.
Okay.
I was gonna say that's not me.
Sorry.
That, if I'm not mistaken, is scheduled for either the 18th or the 25th of February. So hopefully in the next meeting or in the next 2 meetings.
Okay, cool.
If I can jump in here real quick, because I've been mentioning the value of reproducible builds for SolarWinds, and you're absolutely right. PyPy, NPM, and so on, you can push packages, but they don't necessarily have to do anything with the code that was posted, and that's a big problem. I do agree that in the long term, we should have a way to verify, wait a minute, I only want to install Python packages or NPM packages if they've been verified, for example. One challenge is that a lot of packages currently aren't reproducible. So if there's any date timestamps in there, you have to deal with that. If there's any ordered collection, if there's any collection that doesn't have a forced order, you need to change it to force the order, say by doing a sort. It's not rocket science, but it does typically, in typical systems, it does require changes because nobody's ever asked, can the build be reproducible? And so a lot of builds aren't. But Chris can talk about that. It's totally doable. It's just something you actually have to work at.
I don't even think many of the package managers require that you link to the source code.
That's probably true too.
Yeah.
but I think it would be totally doable to say, hey, to modify PyPy so that, in order to submit it, you either have to, or they strongly encourage you, point off to a repo, and then, before it gets installed, it verifies that you reproduce it, or maybe several folks verify you reproduce it. Still have people upload it, just verify it. Now you've got it. But again, it would require changes.
Yeah, I'm working on something similar right now for PyPy. So I'm trying to build a CI pipeline where
who is it speaking?
This is Martin Karnonkurski.
Okay.
So I'm working on something like this for PyPy, where it's essentially something like a CI pipeline that clones the GitHub repository. It tries to build a Python package and then verifies against what is uploaded to the PyPy to give this check mark that can be included on GitHub repository, like a page that this has been verified independently, which is basically the idea of reproducible builds. I agree there's a problem on Python. More specifically, they have a problem that they include the timestamps when the source code was compiled, which often breaks it. But they actually introduced a backport also to Python 2, where you can set a default value just to specifically verify that it's a reproducible build. And it's been completely fixed in Python 3.8, I think, or 3.7. So it's actually already possible right now, but nobody is using that yet. So I'm trying to create a similar tool like that. And there's also maybe a related issue is that there are different kind of formats in Python. So there is a wheel, there are SDs, etc. And in the PEP specifications, wheel are also supposed to be like this no code execution during the install time, but everybody is ignoring that basically. So one of the checks that I'm trying to do is that you can also prove or also display this kind of verification or page that when you are installing some kind of package, that there is no kind of code execution being done during the install time, which is what the wheels are supposed to do. But again, nobody is doing that.
Awesome. That's really interesting. The other thing I like in this area is Docker Hub verified builds. If anybody's familiar with that, they have support for when you publish a container image on Docker Hub, you can build it yourself and push it, or you can just point Docker Hub at the Docker file and they build it for you, and they publish the logs and then add a little badge attestation saying that, yes, they actually built it from this source code at this time, and it's not the person who published its responsibility. It's kind of the Docker Hub systems. So it's not quite reproducible, but it is a nice, like a third party built it and can make that attestation.
I don't think in the long term that's a very strong argument. I mean, what we want is to be able to verify it so that it doesn't matter who built it. We all agree on that what the correct result is. Hopefully, they won't be broken into. But SolarWinds is showing that maybe hoping nobody will ever break into is not a good plan.
Martin, I was just going to ask if there's anywhere we can follow the work that you're doing, or if it's not followable.
Yeah, it's followable. I'm now building the documentation, and let me post the link to the Aura project. I'm trying to document there as much as possible, but it's still very work in progress. So part of that is already published, which is called Aura diff, that is basically trying to diff the two sources of data, which is essentially also checking whether the build is reproducible. And right now I'm trying to build a pipeline that tries to simulate building this package and verify against the pipeline, but that might still take a while.
Cool, thank you.
I'd be very interested in that. Martin, can you share your email? I'd love to chat with you to get better understanding of that later. So.
Yes, of course. I will post it in the chat.
Okay, I will post mine.
Awesome. Any other topics?
This is Chris Horn. I posted a couple things to the Google working meeting notes, just ideas I've been thinking of in terms of identifying critical software. So there are 2 ideas there. And basically what I was thinking about are like, what are the signals you should pay attention to in order to identify them? So one is basically like a economics market perspective. So the packages that have the highest exploit market values are the ones that people care about, right? And then the second one is, it's kind of around the idea of what Martin was talking about in terms of looking at dependency data. And, I've known over the last couple of years now, I guess, Department of Commerce, NTIA is the National Transportation, something like that. It's like this one guy in Department of Commerce who's pushing software bill of materials formats. So I think last meeting I heard that people had been looking at software composition analysis data. I don't know the source of that data, but I do know that there's standards initiatives through MITRE and Commerce. Alan Friedman is the guy at NTIA, Dr. Friedman. And then, but that might, I know there are file formats called Cyclone and SPDX. I don't know a lot of the details here, but that might represent data sources that you could do your dependency analysis on.
Very much so. That's what the whole purpose of them. I'm Kate, by the way, and I work with Alan. I co-chair the formats and tooling working group underneath the NTIA effort. And one of the key elements of an SBOM is literally having what depends on what or contains in this case. So that information should be there, and it's there so that the analysis can get done. And going one hop down and so forth, recursively, as needed.
So do you know of any data sets that exist, or are these all just very new?
There are examples that exist of the source versions of the SBOMs out there, and there's some build versions that are starting to emerge. So one of the activities that's that group's working on is coming up with some example and a reference corpus to be used. So I'd say work in progress. Check back in about a month or two's time.
As far as broadly to identify criticality, somebody's already noted libraries.io has some. The Harvard's also gathered data from specific SCA vendors. One trouble is that doesn't capture everything. That captures like primarily the language level specific packages, but that doesn't capture a lot of other dependencies that aren't captured by the specific language dependency package managers.
So you're saying it's like includes in source code, but not other things? What?
No. Okay, so libraries.io, it captures some package data if you're using a language level package manager. So for example, if you're using Ruby, it'll yank up your gem file. If you're using Python, requirements.txt, packages.json for JavaScript, so it looks at those files and such. But if you call out to, say, a independent executable, that's out of scope. But nevertheless, they still depend on those things.
Sure. So, right. I think what you're saying is that there are multiple ways to invoke dependencies, and not all the methods are good at chasing all the ways, right? So you could have direct, like, get the right word, where you just make a call right to the executable, you fork a process and call it.
Right.
You can include, or you can.
That's right. Right, and that obviously creates a dependency, but wouldn't be captured by a language level package manager, which is why there are these formats like SPDX, CycloneDX, which are able to capture, arbitrary language dependencies. But now you've got to figure out how to, it's great they can capture that data. Now you got to figure out how to figure that out.
Now we need tooling to generate it. Yeah.
Yeah. Yeah, good. Hooray! We have a format. Now we got to figure out how to generate that data in that format.
Yeah, that's pretty much about it. There's all the relationships that are defined. I'll just catch most of the build relationships. And if you see something that's missing that you know we're going to need to reflect, just open an issue. Mm-hmm.
I tried to add to our working group meeting notes, some notes. Hopefully they help.
Thanks, David.
Happy to.
I had one other thing I was going to bring up today, but yeah, sure, why not? We've got about 10 minutes left, and I've been brainstorming so we've been talking about identifying critical projects a bit today. But I've been thinking about the flip side, where we actually inspire projects to make improvements for their security posture. And of course, the security scorecards project we started in this working group and does a bunch of security checks. So I'd be curious what people think about some of these ideas, and if you have some of your own. I think the first one comes to mind is like one of those badges on GitHub. I'm not even sure how hard it is to set that up, but basically, if you meet a defined set of those security checks, we'll give your project one of those badges. Is one idea that I had, and I think we'd have to come up with either like a tiering system or figure out which criteria gets you what badge. And then the other idea that I thought of is just like a bounty rewards program. So we've been learning that it's really hard to like just throw someone at a project and help out. It really has to be the maintainers that are on board and helping make improvements. So the other idea was just a bounty program where if you've met a number of these security checks, or you can show that you've made improvements, that will pay you a reward. What's that, Kate? Okay. So I don't know. Those are two ideas that I had. I'd be curious if you guys think those are good, or anything else that sort of comes to mind to make progress on that front.
If I can jump in real quick, at least as far as making it easy to get implement the tiering system stuff. I mean, the CI best practices badge, we specifically had to do that if people modify their README to point off to something, and as they get better, or hopefully not worse, on the badging project, it shows their current state. So it's not hard to do. A little incantation to yank an image is all you need, and then you just have to serve the right image at the time. The bigger problem, as you can imagine, is figuring out what your tiering system is.
Yeah.
We've been encouraging, for example, folks to earn your best practices badge, and of course that is a tiering system.
Yep.
And that forces folks to write automated tests and use a static analysis tool and all that goodness. To tell people how to report vulnerabilities, the kinds of things you kind of would be hoping they'd do anyway, but it may not.
Yeah.
I love the idea of a bounty program. I think you can't open it up to everybody. There's probably just, at least if it's money, but at least for some selected list.
Right. That's why we need the list.
You ran a large, like for 2 years, they ran a multi-million-dollar reward bounty program. Do you guys know about that?
Yeah, the EU. Yeah, well, I don't know the criteria or what, if it was just bug bounty, like fix a bug would pay you out, or if there was more.
Oh, do they have a new one? I Googled, I searched it, and
yeah, they did 2 iterations. Yeah, it was FOSSA 1 and FOSSA 2, and based off of I wasn't able to go really into the nitty gritty of it, but a lot of it, and you see a lot with really big efforts where a lot of the value kind of gets lost in the in the middle, kind of. So I believe their first program was about $12 million of funding set aside for bug bounties and improving open source software. And if I'm not mistaken, a total of, I believe it was 10 critical CVEs came out of that. So that's about $100,000 per CVE. So not a great hit rate, but just the fact that it was a government-funded initiative to improve open source software, specifically through bug bounties, audits, things of that nature, I think is a great first step. But I think in terms of execution, I think it could have been done better, but of course that's easy to say after the fact. I mean, it was a great effort conducted overall.
Okay.
I feel like many of these programs are too vague, or too general. Like in the case of scorecards, we can have very specific set of criteria, like tiers, like, hey, if you satisfy all these checks, like let's say basic CI integration for fuzzing and other things, that could be a good reward in itself. And we could come up with a good magic number that is rewardable for the time or effort that the developer puts in. So just wanted to see what you guys think here.
Cool. Yeah, I mean, maybe we can take a stab at some, criteria or what a tiering thing could look like and discuss that in the next meeting or so. Get some feedback.
Yeah, and I like your idea, Kim, of creating some documents that we can kind of all collaborate on. I think that's a good approach too.
Yeah, I started the one while people were talking, so I'll share that out soon. Cool. All right, I think that's a wrap for today. Thank you, everyone. And yeah, feel free to add things to the agenda if you want to discuss anything in the upcoming meetings. So, all right, have a good day.
Thanks. Bye.
Thank you.
Bye.